Hello everyone, my name is Sumit Verma and today we'll be solving the easiest ever coding contest at GFG. So let's get started with question number 1. In this question, you are given an array of words containing n strings of same lengths. And in one move, you can choose any position in any one string and change the letter at that position to the previous or the next letter in alphabetical order. So this is an example given here. And what we have to do, we have to find the minimum difference over all the possible pairs of n strings. The difference between the two strings is the minimum number of moves required to make them equal. So here is an example given here, and the answer is 6 because the minimum difference between these two strings is 6. And if you choose any other pair among other than these two strings, then you can find that the distance is greater than 6. Therefore, the answer is 6 here. And if you carefully look at the constraints, then you can clearly tell that we can apply the brute force solution here, because by looking at these constraints, the total number of operations for this question would be, like for this question number 1, the n is at max 50. Therefore, there will be at max 50 number of strings, and this size of each string would be at max 8. Therefore, the total number of comparisons here will be n into n minus 1 by 2 into 8. That is strings length. And if you solve this by putting these values, then you can clearly see that the total number of operations will be 9800, which is fairly a small number. So we can apply the brute force here, and I'll be doing the same thing. I'll be applying the brute force solution here. So we can take each and every string here by writing this. I can have word 1 as words of I, and for comparison purpose I can have another variable that starts from I plus 1 and traverse up to n, and I can have word 2 here equals to words of j. So after having these two words, I have to compare the distance between these two words, and I have to take the smallest distance. So the answer will be initiated by int max, because I have to take the smallest distance. Therefore, I am initiating my answer to be maximum, and I'll be taking the minimum of the answer and the answer that I get after calculating the distance. So I'll be writing a function that is calc distance for word 1 and word 2, that calculates the distance between these two words, and after getting the smallest answer, I'll return that. So let me just write this calc distance function, and it will be taking two words, word 1 and word 2. So let me take that by reference. In that way we can optimize our code, and now we'll be having the number of characters in this word. So we already know that the number of characters in both the word will be equal as given in the question. So I'll take each and every character one by one in both the strings and compare them. I'll just add the distance between the two words one by one into the answer. So answer plus equals to the absolute difference between the character at word 1 and the character at word 2. So by writing that, I'll be having the distance between the two words, and for calculating the distance between every pair of two words, I'll have my final answer. So let's check whether the code works or not. So it gives compilation error because I have not subtracted them. I have to subtract the character of word 1 and character of word 2. So now I am getting my answer as correct, Let's submit that. So yeah, it got submitted. Let's go to the second question. So let's read it. The second question says, the name of the second question is Geek and Buildings. And the second question says that you are given an array of heights of n elements whose ith element denotes the height of ith building. And the geek likes to jump from one building to another building. He only jumps to the next top building if that next building is taller, and stops when he reaches the tallest building. So the energy required for this journey will be the XOR of all the building heights that he has traveled. So I have to continuously take the XOR of all the buildings that I am crossing. So for example, in this case, if I start from 3, then I surely be jumping onto the other building that is greater than 3, which is 4. Now from 4, I will be jumping to 5. From 5, I will be jumping to 6. And my journey will be end at 6 because it is the largest building. Doesn't matter if there are more buildings ahead of it. In this question, it doesn't matter if there are more buildings ahead of 6, because 6 is the tallest building to the right from this index where I have started my journey. So let's say, let me go to the whiteboard. So now we are talking about question number 2. So let's say that we have an array like this: 4, 2, 3, 5, 6, 8, 2, 9, 4. So if you start your journey from, let's say, this index, then your journey will be like this. Now from here to this, now from here to this, from here to this, from here to this. So the answer for this journey would be 2 XOR 3 XOR 5 XOR 6 XOR 8 XOR 9. And you can clearly say that every building that I am jumping on is clearly greater than the previous building. Before solving the question, let us look at the constraints. So there will be total number of n buildings, and the range of n is 1 to 10 to the power 5. And the height of each building will be between 1 and 10 to the power 9. So we can clearly say that if you try each and every combination, then we can't pass this question because the constraints are too high for that. So basically we can't apply brute force here, and we have to think something optimized approach. So the hint for that would be to use the algorithm of next greater element. So you can realize one thing: if you're say at this index, at this height, then you can only jump to the next greater height. Okay, so that is the logic. So if you just find the index of the next greater height for each and every index here, then you can easily solve the question by traversing from right to left. Why I'm saying right to left? Because let's say you have calculated the answer for this index, okay, and now you are claiming that you are jumping from this height to this height. So if you already know the XOR value of the journey starting from this index, then you can take that answer and XOR it into the 5 here. So let us say that you are jumping from 3 to 5 here, okay, and you already know that the XOR value of the journey starting from 5 is, let us say, x. You already know this. Then the XOR value of the journey starting from 3 will be nothing, just 3 XOR the XOR value of 5, that is 3 into, sorry, that is 3 XOR x. Okay, by using this logic we can solve this question easily. So let us just code the solution. So let us say that I have a vector int positions of next greater element array here, or we can say vector int here. And for having this vector, let us say I have created a function that is get nge, that is get next greater element, and this function I'll be passing heights and n. So I'll be writing this function later on. So let us just complete the maximum energy function. So for having the final answer, I'll be having a variable answer, and since I have to maximize final answer, then I'll be initiating this with int min. Let us have an for loop starting from n-1 and going till 0. Since I have already told you that I'll be traveling from right to left, therefore I am having this for loop for depicting the same thing. Now if the position of next letter element for this particular index in the array is, let us say, -1, this -1 indicates here that there is no other greater element for this particular ith index. This signifies that you are either at the last index or you are either at the index where the largest element resides. Okay, so that is clear now. When you are at the last index or you are at the index at which the largest number resides, then you will have the answer as -1 for this vector, which gives you the index of the next greater element in the right position. Okay, now let's, oh, I have named this vector incorrectly, so I have corrected that. Now I'll be maximizing my answer variable by taking maximum of answer and heights of I. So when you are at the position where there is no other element that is greater to the right of that index, therefore the answer for that journey would be the number itself. For example, the journey starting from 9 would be equals to 9. The journey starting from 4 would be equals to 4. Now let us take the condition where there exists a number that is greater than the ith index and to the right of it. Then we'll take the answer and we'll maximize it by saying max of answer comma height at ith index XORed with heights at positions of NGE of ith index. So this will be giving the value of the ith index, and this will be giving the value of the journey starting from the position of NGE for the ith index. So now I'll be updating my heights of I, because by doing this I can reuse it when I go to the left. Now in order to solve this question, I have to just return the answer. Now before doing that, I have to complete the function get NGE. So let us do that. So the return type of the next NGE would be vector int. Now in order to implement that, I'll be using a stack st, and I'll be having a vector int through which I'll be returning the result. So I'll be naming this as vector int result, and let us give it dimension of n, because there will be n indexes for which I'll be calculating the position of next greater element. So this result vector will be becoming our position of NGE. Now let us start by traversing from right up to I is equals to 0. Now if the stack is empty, then the result that we'll be putting at ith index will be -1, because there is no other NGE at the right of this index, and we'll be pushing this index in the stack. So let us take the case where the stack is not empty, therefore the answer might exist. Then we'll check that the heights of the top of the stack. So the top of the stack would be an index, and the heights of that index is greater than the current element. that means the top of the stack is having the index of the next letter element. Therefore, we'll be putting the result is equals to top of the stack, and we'll be pushing this index into the stack, because if there is another element that's coming after updating I that is even smaller than this height, then the result would be again the top of the stack, that is the index of this height. So that was clear, I think. Now if the height of the top of the stack is less than or equals to the height of the current index, then we can say that we have to check while the stack doesn't get empty and the height of the top of the stack is less than or equals to the heights of current index. We have to pop the elements until the stack gets empty, or we find an element that is actually greater than the current element. So after getting out of the while loop, you have to check whether the stack is empty or not. If the stack is empty, then unfortunately you are at the position where the height at the current index is the maximum height of all the heights. Therefore, there were no element having greater height than the current index. Therefore, the result for this index would have been -1. Now, if that was not the case, that therefore this stack was not empty, therefore you can say that the result will be at the top of the stack, because heights of the top of the stack for that case would be greater than the heights of current index. Now at finally you will be pushing I in the stack. Now after doing all this, you have to just return the result vector. Now let's check whether the code is correct or not. So I am having some issues here. Oh, I spelled the position of NGE wrong here. So let me correct it. So it's showing that the answer is matching. Let us try to submit this code. So it ran, it passed. Let us go to the next problem. The next problem's name is problem setting at GFG. So in this problem you are given you are a problem setter at GFG, and you have to select a set of problems to create a contest. For this, the company provides you a selection of n problems, and the difficulty level of each problem is given in the problems array. Now the problems array is non-decreasing array, and the criteria for selecting the problem is select a subset of the n problems which is non-decreasing. Okay, for any pair of consecutive elements, that is a0 or a1, in the selected subset, a1 should be greater than a0. Okay, that is fine. The difficulty level of any problem a1 should be greater than its previous element. Okay, that is the same thing. The difficulty level of any problem a1 should not be greater than the twice of its previous problem. Now this is the tricky part. Find the maximum number of problems that can be added to a contest. Okay, so for this problem also we have to traverse from right to the left, and we have to check whether the right element is greater than the left element or not. And if it is, then before including it in the contest, you have to check whether the right element is smaller than this twice of the previous element, that is the left element. If that satisfies the both of the conditions, then only we can say that we have been including both of the questions. So let us start coding it right away. So for that I'll be traversing from right, and I'm not thinking of traversing from n-1, I'm thinking of traversing from n-2, so that I can easily compare it to the I plus 1th element. So let me write this. So I'll check whether the problem's difficulty level, that is problems of I, is smaller than problems of I plus 1 or not, and if it is, then I'll again check whether the problems of I, that is the smaller element and this is the greater element, the problems of I into 2 must be greater than or equal to problems of I plus 1. So basically I'm stating this condition, that is the next element, the next problem should be less than or equals to the twice of the previous element. If both of the conditions get satisfied, then I can count it. So let me create a variable count and let me create a variable answer to have the final answer. If both of these conditions get satisfied, then I can count this problem. You can notice one thing here, that if you're counting this problem, then your count should be initiated with 1. So if you're counting this problem to be in the contest, then the total count would become 2, because this problem you can take in the contest already before checking this problem with this problem. And if the condition doesn't get satisfied, then you can reinitiate the count with 1. That is not taking the I plus 1th problem and taking only the ith problem here. At each and every step you have to take the maximum of answer comma count. Now just return the answer and let us see whether this code works or not. So it is giving me the expected results. Let us try to submit this. So okay, I'm getting it stuck at the case where the answer is 1 and the number of problems is also 1. So I have to reinitiate my answer with 1 only. Let us try to submit this. Okay, so the problem gets submitted. So let us now go to the next question. The next question is array game. In this question you are playing an array game in which you are given two arrays ARR and BRR, and the size of each array is n, and each array is a permutation of n positive integers. And in one operation you can perform either of the two steps. First step is to rotate the array ARR anti-clockwise, and the second step is to remove the first element of both the arrays if they are same. Find the minimum number of operations required to make both the array empty. So we are basically given this array and we have to rotate only this array. So since both the front elements are not matching, so we'll rotate this array until they match, and we'll do this until we get both these array empty. So let us straight away go to the code. So let us start by defining a queue, and let us put all the elements of array A into queue. Now we'll iterate over array B, that is BRR, and we'll rotate the array ARR, that is popping element from the front of the array ARR and pushing it back to the end. And we'll do this until we get the queue stop equals to the BRR of I. We'll just push the front array again into the queue and we'll pop the front array. Now one more thing, we have to calculate the number of operations side by side. Now every time we're pushing an element to the queue and popping the front element, we have to increment the number of operations here by 1, and every time the queue stop gets equals to BRR, we'll be popping the element from the queue, and that also includes one more operation, and we'll do this until we get both the queue and the BRR empty. So we'll basically return answer after that, and let us check whether the code runs or not. So it gives compilation error saying that there is no such a thing as P here, it is Q. Again compilation error, so Q stop, okay, it's front, my bad. Now it is getting the expected output. Try to submit this. Yeah, it got submitted. Name of the question is beautiful number. Given n, check whether it is a beautiful number or not. And the beautiful number is defined by the following processes. starting with any positive integer, replacing the number by the sum of square of its digit. Repeat the process until the number gets equal to 1, or it loops endlessly in a cycle. Those numbers which ends with 1 are beautiful. Okay, so we can straight away apply this logic by having a while loop. Check whether the given number n ever gets equals to 1 or not, and if it never gets equals to 1, we'll just keep on going, checking whether we are trapped in a loop or not. So we'll take n until the n gets equals to 0, and we'll take its digits and we'll keep some variable here to store the sum square of the digits of the n. So we'll take sum and we'll plus equals to the n modulo 10, that is the last digit of n, into n modulo 10, and we'll decrement the n by dividing it with 10. Now we'll replace n with sum every time after we have calculated the square of sum of its digit. Now to check whether this while loop is getting into an endless cycle or not, we have to take an help of unordered map. Now every time we'll get a number n, we'll check whether this number has already been encountered or not. So we'll check it by using find function. If the find is not getting us the end of map, then we can definitely say that this number has already been encountered, or we are trapped in an endless loop. Now if it is not the case, then we can store this n in the map for the future reference. Now if the while loop ends with n being equals to 1, then we can clearly return true here. Let us run on the sample test case. So it is running. Let us try to submit this. So it is getting submitted. Now let us move on to the next question. The next question is maximum number. In this question, the geek is participating in the coding contest. His score n contains only the digits 7 and 9, and he has the power to update his score by changing at most one digit. So he can convert a 7 into 9 or a 9 into 7. So in order to get the maximum score, we'll obviously convert a 7 into 9. And one more thing we can make sure here, that we can convert this 7 having the maximum place value to 9. And to get the 7 with the maximum place value, we can use the concept of stack. So we can have a stack here, st, and we can have a while loop through which we can take the digits of num and store it into the stack. Now stack dot push will be pushing the last digit of num into the stack, and we'll be dividing the num by 10 every time. So at the first time the number will be 9779. In the second iteration the number will be 977. In the third iteration the number will be 97, and then 9, and then 0. When the number gets equals to 0, this while loop ends, and we'll just reiterate through stack to get the first 7 having the maximum place value. And to find that, we'll use a bool variable found, and we'll initiate it with false. Now if this stack stop is equals to 7 and we have not found the first 7, then we can say that the new number will be number is equals to number into 10 plus 9. Else we'll compute number is equals to number into 10 plus stack stop, and after each iteration we'll just pop from the stack and just try to return the num. So let us see whether this code runs or not. So it is giving us the incorrect answer because we are not updating found after getting the first 7. So we'll update found as true. So now let us see whether the score is correct or not. Yeah, score is correct. Let us try to submit it. Yeah, it got submitted. Now let us go to the next question. The next question is complete the staircase. In this question, Geek has n bricks. He needs to buy a staircase consisting of k rows, where the ith row has exactly I bricks. If he starts from the first row, then find the number of complete rows of the staircase that he will build. That for the ith row, the number of bricks will be I. Therefore, for the first row, you will have 1 brick. For the second row, you will have 2 bricks. For the third row, you will have 3 bricks. Now, if you have only n bricks, then how many rows can you completely form? This is the question. Now, to solve this question, let us take the most optimal case where you have, let us say, n bricks, and these n bricks are sufficient enough to complete capital N rows. Okay, so what would be the sum of what would be the value of n if you have to complete the capital N rows? Now you can clearly see here, if we want to complete 3 rows, then the number of bricks that we want is equals to 6. Now if you look at this carefully, you can calculate that for the nth row, the number of bricks that will be required is n into n plus 1 by 2, because this formula gives us the summation from 1 to n. Now basically we have to compute the largest n value such that it is less than or equals to small n. Now if we solve this equation, we will get this. Now you cannot solve this quadratic equation without engaging the complex numbers here. So the best that we can do here is we can solve for this. So here we can have the candidate n, that is the possible number of rows that we can create using small n bricks. So that candidate would be equals to 2n. Now we'll just check whether this candidate n into n plus 1 is small less than or equals to 2n or not. So if it's actually greater than 2n, then we'll return n minus 1. And if it is less than or equals to 2n, then we'll straight away return this n as it is. Because in that case, these much number of rows will be insufficient enough. Because this n is satisfying this equation, which is sufficient enough to solve this question. Now let us try to code this. So we'll take n, that is square root of 2 into n. And instead of writing 2 into n, the better way would be to write n left shift operation 1. Because left shift operation and right shift operation are much faster operations. So we'll just check whether this n into n plus 1 is greater than this 2n or not. If it is greater than this 2n, then we know that the answer is n minus 1. Otherwise the answer is n. Let us try to submit this. It successfully runs on this test case. Now on submitting, let us see what is the result. So it got accepted. Now let us move on to the next question, that is count the substrings. In this question, you are given a string s and you have to count the number of substrings which contains equal number of lowercase and uppercase letter. Okay, so this question can be translated into an entirely different question, which is similar to solve, and this would make the question much easier. So in the test case, it was given that women days as an example. So here we can notice that the first substring that we can form here is this, and the second substring would be this, and the third substring would be this, and we can keep on going to check all the substrings. But on noticing these constraint values, we can clearly say that the brute force way is not going to work. So what we have to do in this question is, we have to re-illustrate this question into an entirely different question. If we replace all the capital letters with -1, and if we replace all these small letters with +1, then we can form an array having only +1 and -1. In this case, it looks like this. And if we calculate the substrings here, now if we calculate the subarrays here having sum is equals to 0, then we can easily solve this question. And we can do this in a very efficient manner using map data structure. So let us try to do this. So we'll have a map here. So this map will be helping us to find these subarrays having sum is equals to 0 when we convert this string into this array. So let us first convert this string s into an array ARR of having size n, where this n is equals to the size of s string. Now we'll iterate through the string s and we'll check whether the given character is small character or not. If it satisfies this condition, then the s is small character, and we'll replace the ARR of I with +1 here. Else we'll be taking ARR of I is equals to -1. Now we'll just have to calculate the sum for all calculate the prefix sum for this array ARR and check all the sum values that we get and store it into the map and try to calculate all the subarrays having sum is equals to 0. For that, I'll be iterating through this ARR. And if you already don't know this algorithm, that you must learn this algorithm where you can easily calculate the subarrays having sum is equals to 0 using a map data structure. So first I'll initiate the map with 0 with a 1 frequency of 0. Then I'll take a sum variable and I'll keep on adding all the array elements, and I'll try to keep the frequency of sum into the call. Now I'll iterate through this map and I'll reinitiate the sum with 0 and I'll take the p dot second here, that is the frequency of the particular sum value, and apply the formula of selecting 2 numbers out of n numbers and into n-1 by 2. So if we try to return this sum, then let us see whether this code works or not. Okay, it is working here. Let us try to submit. So this was the solution for all the questions in the contest. This was the first, then the second, then third, then fourth, then fifth, then sixth, then seventh, then eighth. All the 8 solutions are solved by me here. So thank you for watching.